This is Derek Comingore, and I'm going to be walking you through the first couple of slides in our session here, which talks specifically about the TPCC benchmark. And even more specifically, beyond the benchmark itself, we're going to share with you some best practices and lessons learned in terms of performance tuning and getting accurate, optimized Yugabyte TPCC benchmarking results. So the agenda is the TPCC review. So I'm going to walk you through the TPCC benchmark. I'm also going to take you through the Yugabyte TPCC application. And last but certainly not least, some phenomenal results that our engineering team here has published out. And they're very exciting results. I'm super pumped to share those with you. And then we're going to turn it over to my co-presenter and colleague. She's going to walk you through some of the preparation and warming and results analysis information. And I'll be covering the infrastructure and summary pieces as well. So with that, and I also want to add and should add that I'm a pre-sales engineer here at Yugabyte. My name is Derek Comingore, and I have a long history working in databases, starting with single nodes and then distributed databases. And am very excited to be at Yugabyte working on a very modern approach to challenging, demanding transactional database applications. So with that introduction, the TPCC review here, if you're not familiar with the benchmark itself, this is just a little bit of information. This is by no means exhaustive in nature, but it will get you started on a good path to understanding and learning about the benchmark. So TPCC is a transactional database workload benchmark. So you don't use this for decision support or analytic purposes and use cases. But if you have demanding kind of puts and gets, read and write workloads that you're facing in your organization, and you would like to see how new technologies that are solving this challenge in a very unique, efficient way, I should add, and you want to see how they perform without actually taking anything from your workload or anything unique to your company, this is a fantastic way to gauge performance. And you can compare results across vendors, across databases, across different types of data platforms, to use that terminology. If you're looking at even something that's not a true database and the typical definition of that. So that's what the TPCC is. It's a standard benchmark. It's been around since 1992. You might wonder why it's still around and relevant. Well, that's because it continues to be the most mature, objectionable, reasonable, realistic benchmark for transactional applications. There have been newer benchmarks that have since come out, but this is the tried and true benchmark. And so even today in 2021, even though it was created in 1992, which seems like forever ago, it still continues to this day to be the gold standard. And we're going to talk about the results interpretation and analysis in a little bit, but for now, there is the TPMC metric. This is going to tell you the number of new order transactions processed per minute. This is only one of many different types of transactions, both physical and logical transactions that occur in the TPCC, and some of those are actually listed here above. If you're not familiar with the scaling factor on this last point, you scale the benchmark out by number of warehouses. This is the volume and the volume as well as the workload itself on the database. It's by number of warehouses because this is a wholesale parts supplier scenario. So if you kind of think about what that business model looks like, in this case, you would scale that business operationally speaking by number of warehouses. And that's how you scale the benchmark likewise. So you can start small with like 10 or 100 and go all the way up to thousands. And in fact, there's a great work by our team here, and you're going to hear more about this in just a little bit. They've even cranked out 100,000 now in terms of the number of warehouses that Yugabyte has successfully processed. So before I share those phenomenal results with you, I just want to talk a little bit about the Yugabyte TPCC application itself. We have forked and modified and optimized the popular OLTPBench application. If you're not familiar, this has been started and maintained by a lot of very notable folks in the database research community. It is like the benchmark itself. It is kind of a tried and tested and true, proven, what have you, application to execute TPCC. It has a few requirements, but they're pretty minimal. Apache, Ant, and Java. It's pretty bare bones in that regard. It is a multi-threaded load generator application, so it does spin up multiple threads, something to be mindful of certainly when we talk about the client nodes involved here. It provides metric and raw data collection utility to you. So it's actually collecting metrics and some raw data, and it's going to provide some really interesting, useful output that our teams continue to modify and enhance actually as well. We maintain this for database testing purposes for our own usefulness, but we also have made this open source. And the beauty of doing that is you can take the benchmark, you can clone it, download a specific release of it, and you can run these benchmarks just like we do internally, but on your cloud infrastructure and your cloud providers of choice, and on your specific infrastructure, whenever and wherever you want to do it. So this really frees you up to go out and see what your actual output and results are like on your specific workload of the TPCC scale factor, I should add, and your specific infrastructure. We do also maintain a public docs page. So if you go to docs.yugabyte.com, you'll see our kind of index there of all our very useful useful docs articles on the Yugabyte technology stack. If you just type in TPCC in the search bar, you're going to immediately get a one or two result set come up. Just click that link, and right there it takes you to how to. It's going to provide you some very useful complementary information actually to this session that we're providing you today. But it's going to walk you through how to download, run the benchmark, and some information on the results there as well. Again, we talked about the why a little bit. You can also submit pull requests. I did not mention that earlier, admittedly, but like any open source project, there's nothing stopping you as a valuable community member to submit, fork the repository, do your software development on it, make code changes, and then create GitHub issues. I should be complete on this topic as well. And then submit your pull request back to our repository, and we'll review it like the Yugabyte database repository itself. And if we find it's a good fit and there's no other changes needed, we will accept the pull request like any other open source repository we maintain. So you can submit the pull request as well. And last but not least, you can gain visibility into all the great work that's going on. We do actively work on this to be clear on this. This is not something we simply copied and didn't do anything to. This is something we put a lot of effort and investment into. And again, that investment is for two key purposes. It's for us internally to continue to have better optimized, more accurate results, as well as for you as a value customer to run those benchmarks yourself. Okay, and last but not least is the published results. So before we actually take you to the best practices and performance tuning, we just want to share with you a few very interesting, I think you'll find, data points here. So if you are familiar with TPCC, 10 warehouses is pretty small in terms of volume and scale of workload of the benchmark. 100 is still pretty small and somewhat trivial. But when you're getting up to 1,000, and especially when you're getting up to 2,000 plus on a pretty, I'll say simple or standard 3-node cluster of a database, this is where you're really starting to push the database in terms of what that infrastructure can do, regardless of the software running on it, what it can crank out in terms of total throughput from a TPCC perspective. And so for 1,000 warehouses on Amazon infrastructure, we cranked out 12,563 TPMC result on that cloud provider. We then moved over, so we're not even constraining this to a single provider, we're moving over to Azure now, and we obtain almost near linear scale, actually, on another TPMC number of 25.4. And then last but certainly not least, we have actually cranked out 10,000, and there's even a bit of an Easter egg, although it's not an Easter egg because it's clearly shown to you here, but we've executed successfully both 10,000 as well as 100,000 warehouses at this point. And there's the TPMC number on the 10,000. Again, now this is back to Amazon. And there is a second session that my colleague here, she's going to introduce herself here in a few minutes. She's also presenting on that 100,000 execution. Again, if you are familiar, I think this is going to be familiar to you, obviously, but that is a phenomenal amount of workload to be thrown at any transactional database. So both of us here have a long history, including transactional databases and key value stores. So it's a very, very impressive result to have 100,000 successfully executed on any infrastructure or any database at all. So highly encourage you to check that session out. And there's also recordings of these videos. So if you don't have time to make the live session of the 100,000 TPCC, please check out the on-demand recording. Okay, and the next section, which is part 2 here, is we're going to take you through the TPCC best practices and performance tuning. So we've ran a lot of these benchmarks, both internally, as I've mentioned a few times, but also for some very valuable customers of ours. And when you're doing this, you know, like any iterative process, you learn, you observe, you learn, right? You take your learnings and you reincorporate and you iterate and you iterate. And of course, you know, things are getting better. And so with that, some of these best practices very recently are in our docs page, actually. So you'll find some of this information covered, but some of this information is above and beyond that as well. So this is the core part of the presentation here. So with that, the infrastructure is the first key topic here. You really need to make sure that you're planning proper infrastructure if you want a good, accurate Yugabyte TPCC result. And specifically what I mean by that is having 16 plus vCPU based hosts. This is very important. All of our docs pretty much at this point will tell you that if you want to run production quality workloads, you really need to consider 16 plus vCPU. So likewise for the benchmark purpose, you should also have 16 plus vCore. On the RAM, very similar note, 32 gig minimum. You can go up if you want to go up, but highly recommend if you do want accurate, good results here, do not go any lower than 32 gig of RAM per host. And last but certainly not least, on the disks themselves, local SSDs is exactly what Yugabyte has been designed and built for. So another advantage we have is not being a database that's been in the market for 30, 40, 50 years, is we have these newer hardware advances already when the database was being designed. And so because of that, we do very well with solid state technology. If you have access on that note to non-volatile memory NVMe disk, you know, feel free to use those, take advantage of those. Those do tend to have even higher IOPS levels on them. Either way, we work on any mainstream supported solid state drive technology. These are local solid state drives. I should add that as well. And your volume, the density of the drives should be sufficient here on a side note for your intended benchmark scale factor and your volume of that workload. So again, the more warehouses, the more workloads going to be placed on it. So just plan accordingly. The database cluster nodes themselves, this is going to be driven also by the number of warehouses and the scale of your benchmark. Always start with 3+ hosts though, and a very equally important point, use our default recommendation, please, of a 3 replication factor. If you're not familiar with the RF setting in Yugabyte, but you're familiar with other databases, this is going to be somewhat similar in that it's the number of copies that you maintain of a specific shard, to use that nomenclature of data. So if you have a single logical table and you break that up into n number of shards, every one of those shards, in our terminology, we call a tablet. And every tablet has a leader and follower tablets. And so that replication factor represents the total number of copies of that sharded data. So please use our default recommendation of 3. If you would like to evaluate the RF factor of 5, more than, you know, we highly encourage you to do that as well. But the RF factor of 3 is good for maintaining good high availability and still getting very good benchmark results as well with the balance there. Consistent hardware across the host in a single AZ. So like any other distributed database technology, we obviously don't want mixed matched hardware within the cluster itself. Please use consistent hardware, the same, you know, chips, the same memory, and same memory chips, the same drive manufacturer, the same IOP setting, IOP disk capacity capabilities there. Don't use anything heterogeneous, please, in nature. You will get inconsistent results. And last but certainly not least is client nodes. So the client nodes is where you actually run and host the Yugabyte TPCC benchmark application. This is where you can use a single client for up to 2,500 warehouses. We've had good results with a single client powering up to that. And again, 2,500 is nothing to sneeze at or anything else you wanna put in there. It's a significant amount of work. So with one client host, we've cranked out successfully 2,500. If you're going to go beyond 2,500 though, we do highly recommend you go to multiple client nodes. And you can see some best practices and additional information on our doc slide about this as well. It actually walks you through running multiple clients in one particular benchmark up there. So it'll take you through that process. The client hardware should be driven by the number of again, the workload scale factor attribute of all this. So the number of connections, the scale factor, that should drive the client benchmark node itself. We do typically tend to use the same hardware as the database node. You'll see that in the docs, but that doesn't necessarily mean that you should always do that either. So just plan again in terms of your client hardware, and you'll get good results. Last but certainly not least is on the client nodes, that is ensure they do have, of course, cluster access. My voice is going out a little, pardon me. The database access is there for the client node, and they're located in the same availability zone. And I don't believe I did call this out, so let me back us up just a little bit for a second. We do recommend you run these in the same AZ. Now we have, in terms of, again, investments made here, we actually have now are doing global geo-partitioning TPCC benchmarks, very recently as well. But for the purposes of this session that we're in today together, keep it to a single AZ. Okay, and with that, I'm going to go on mute, and I will turn it over to you, Sonal.
Yeah, thanks, Derek. So hello, everyone. Myself, Sonal Agarwal, and I'm a QA with over 11 years of experience and currently working on performance profiling of Yugabyte. So as mentioned by Derek, we have a Yugabyte TPCC application, and so talking about the enhancements, we have done a few enhancements to this application. Talking about so like the enhancements, like we have gone through all the SQL statements that are executed in the transactions, and we have done the optimizations to get the better throughput for these SQL statements. We have also done changes wherein we improve the efficiency, like we are retrying the failed transactions. We are calculating the number of transactions that are run in the steady state. I'll talk more. We have covered all these in details in the session of part 200K warehouses. So but one more change I want to talk about here is that we have made changes in the result output of TPCC that we see. So we have added detailed information about the failed transactions, the number, the rate of failures, how much retries we have done, and also we have provided the information about the connection latencies that help us analyze the results and concentrate on the performance bottlenecks and the areas of improvements. The other thing about the improvements, if I talk about in the TPCC application, is that we have introduced this results output in the JSON format. Yeah, so more about this again in the part 200K session. Okay, so we recommend using the latest source code for getting the better throughput here. The other thing that the other recommendation is you're using compactions. So compactions is basically we reclaim the disk space due to overrides or deletes that are already happened in the database. And since TPCC being a mixed workload, there is new data entering into the engine continuously. So reclaiming the disk space is very important here. So to perform compactions, we have different tools here. The YB-admin tool, which allows us to manually compact the data at the table level here. And we also have one other tool here, which is YBTLS-CLI, which allows us to compact the tablets at the T server level. Moving on to the other recommendation here is the warm-up. A database actually may take some time to reach to a good performance, and the time necessary for the OS and database to cache and load the necessary data. So hence, warm-up plays an important role here, and you can run the TPCC with the -- warm-up time seconds parameter. Yeah, there's a next slide. Yeah, so once you have the successful run of TPCC, you will see output would be something like this. This is just a snippet of the output that you see here. If I walk you through the output, so the first thing is the TPMC. The TPMC is transactions executed per minute. Efficiency is derived from the transactions executed per minute here. So we record, as mentioned, we record different latencies here, like connection, the transaction level latencies, which is the average latency that the time required by the transaction to execute. Along with this, we also have the connection acquisition latency. This is also an average of across the transactions here. The output you see is currently is for only the new order and payments, but we have this information for all the transactions run in the TPCC, and also an aggregate information for all the transactions run. So there is an aggregation for all also provided here. The next section in this output is the failure latencies that we see, the count, the number of failures that we got for a particular transactions, what was the latency for that transactions, and again, so we also, as mentioned, we also retries the failed transactions, and then the retry attempts are mentioned in the last section here, wherein we mentioned the count of the particular transaction that were executed, the first execution, and how many failures were there in that execution. Then after retry, how many like still failed after first retry, and then we again have so these retry is again configurable from the TPCC application. So we have in this run we have retried 2 times. So we also specify the split up of each transaction that is running, this time spent in for each transaction in different phases. So there is a fetch work phase, the keying phase, the operation with retry, and the thinking phase. So we provide the split up also, and all this information actually helps us in detailed analysis of the TPCC runs. Yeah, thanks, Derek. Over to you.
Thank you, Sonal. Excellent. So in terms of the, well, bear with me 1 second. In terms of the key session takeaways, just a few things we want to leave you with as we wrap up our session here. In terms of summary takeaways, so leverage production quality infrastructure for both your database, your TPCC database cluster, and the client nodes themselves. Again, make sure that it's high quality components that you would literally, be considering deploying if you do deploy Yugabyte in a production environment. It should be something of similar quality. Secondly, plan and execute your TPCC executions, including scale factor, warm-up time, the versions, so the versions of the database, as well as the version of the Yugabyte TPCC application. Plan all that out. We actually did not talk about the database version itself today because it's a little bit of a side topic. It does correlate to this topic, but it's related and yet not directly in this topic. So think about the database versions as well. We have a odd and even release cycle. So this is, again, another topic very well documented up on docs.yugabyte.com. You can learn about the releases and plan out which specific database version that you would like to target for your benchmarking. And then last but certainly not least is, your understanding and interpretation of the TPCC output that we just walked you through. So getting familiar with that output. And by the way, the team here continues to make good work and improvements on that output. So it's something, even if you learn it today, right, it'll likely get even better in another few weeks or months. So getting current with it, understanding what that output represents that we just walked you through, the retry attempts, the connection latencies, of course, the main metrics, the efficiency number and the larger metric of the TPMC itself. But these are all good things to take away from this session today. And with that, if you do these three things and you do these three things very well, you will have an optimized, accurate, good, solid Yugabyte TPCC benchmark. So with that, we both want to thank you for the time today. Highly encourage you again to check out the 100,000 TPCC warehouse session as well. That's a phenomenal amount of work and an actual benchmark that our team accomplished there. So have a fantastic day. And again, thank you for the time.
Yeah, thank you.